Dear students, welcome and thank you for tuning in to this video of Stacks and Dynamics with me, Dr. Loay Al-Zube. And today we're going to be discussing equilibrium of rigid bodies. So you probably wondering as an engineer or a student of engineering, you've heard about the concept of equilibrium over and over again. And you're wondering what is a real life application of equilibrium that you could be working with. And for example, it's important to be able to find the forces or determine the forces in a cable used to support let's say those ramps in the picture that you're looking at, so that they does not fail. So you need to select the material that they are actually made of and what those support cables are. So we're going to be in this video we will learn, and I will give you everything you need to know about how to identify support reactions for a rigid body, as well as how to draw a free body diagram of a rigid body at equilibrium, or why it's important to do so in order to apply it in selecting and identifying, selecting the cables and identifying the forces in the cables to support the ramps. Also, I will have for you detailed description and sequence of steps in order to be able to draw a free body diagram so that you can use the equations of equilibrium to identify unknown support reactive forces. So let's dig into this. So the first thing, let's talk about the applications. So if we look at this ramp, the truck ramp have a weight of, let's say, 400 pounds, and we have two of them, and each ramp is pinned to the body. Pinned is a very important word to consider. So the ramps are pinned to the body of the truck and held in position by a cable. And again, as I mentioned before, you could be encountered with the task to determine the forces in the cables so that you can select which cables to use. And so how can we determine the cable's tension and support reactions? So this is something we're going to be discussing in this video. Also, how are the idealized model and the free body diagram used to do this? So we start with a real life structure like ramps on a truck, and then you need to move to an idealized model, which is the picture in the middle, and also move that idealized model into a free body diagram, which is the picture to your right. So this answers your question, which diagram is the idealized model, which is the one in the middle. And if you notice in the idealized model, we have the pins at point A, two of these pins at point A and the point above it. And we are going to use a lot of these support reactions. So it's very important for you as an engineer or a student of engineering to be able to identify which type of these support reactions are present in your structure. And because each of these, they have a different set of reactive forces to be replaced with, and we're going to discuss that in the coming videos. Another application, so we have these two smooth pipes and each having a mass of 300 kilograms, and they are supported by the tines of a loader or fork attachment. So this is another real life application. How can we determine all the reactive forces? And again, we're going to talk about the reactive forces, and they are supposed to prevent translation and rotation. And we will discuss this in more details. But I'm just showing you the application. So here you can make a use of idealized model, which is again the picture in the middle, and a free body diagram to answer this question. So we will learn how can we replace all these surfaces of contact in this picture, which is this one and that one. How can we replace them actually with reactive forces? T and F and P as a whole, as a system. And this is something we're going to be learning in this chapter and the videos that are going to follow. So, we learned about the equations of equilibrium in previous lectures of a particle, right? And if you remember, we said that when a particle is in equilibrium, the vector sum of all forces should equal to 0. And if you took the x, y, and z components, you can create 3 scalar equations of equilibrium for that particle. And remember, they are valid for any point in equilibrium. So we discussed this before, and we said, okay, this is a particle. If we are analyzing the forces, the only thing we need is just make sure that the summation of forces in all directions is equal to 0, and we assume the particle at equilibrium, right? Now, if you recall the structure that we talked about, the picture that we mentioned, the 2 pictures we made and the examples we mentioned above, they're not particles, right? We call them rigid bodies. So in rigid body equilibrium, we have a unique situation, a different situation from the equilibrium of a particle. So this is forces on a particle. When you discuss rigid bodies, in contrast to the forces of a particle, the forces are not usually concurrent, which means they may cause rotation of the body due to the moment created by the forces. So in order to have equilibrium, static equilibrium for a rigid body, we need to have 2 conditions to be satisfied. We need to make sure that you have to test and make sure that the forces, summation of all forces equal to 0, and so we don't have translation, and also summation of all moments about an arbitrary point must be equal to 0. And the 2 equations are not only necessary for equilibrium, they are also sufficient. And that's very important when we're analyzing a rigid body. I hope that this clarifies the difference between studying the equilibrium of a particle and studying equilibrium of a rigid body. So we're going to go one step further in analyzing structures. All right. Now, going back to our example that we mentioned before, so what is the process of solving rigid body equilibrium problems? And this is what I told you about at the beginning of the lecture. So if we started with our example of the ramps on the truck, to analyze the actual physical system, first we need to create an idealized model. And when we mention idealized model, we just make sure that we have the dimensions and we have the points of attachments and contact, and also you need to make sure that you are showing the reactions, the force reactions or the reaction structures. And here there are the pins that they're attaching the rams to the truck, and also that attach the cable to the truck as well. Once you have this idealized model, then we need to draw a free body diagram showing all the external forces, active and reactive forces. And what we mean by active are the weights, and reactive forces are the forces created by the pins or the that prevent translation and rotation. Finally, we need to apply the equations of equilibrium to solve for any unknowns in our system. And that is how actually this is the process of solving a rigid body equilibrium problem. A quick, summary of how to draw the free body diagrams of rigid bodies. So let's say that we have this, structure that is pinned into the wall, and this beam is experiencing a 1200 newtons. So how can you move from this into a free body diagram that simplifies and makes the analysis of equilibrium easy for us to do? So step 1 is going to draw an outline shape and imagine the body that's been isolated or cut from its constraints and draw its outline shape. So we will cut it from this point, and then we have our beam isolated. And then step 2 you need to show all external forces and couple moments typically included. So let's say applied loads. So this is 1200 newtons, and also the weight of this beam at the center of gravity, and also at the support reactions. The support reactions are the pins, and the support reactive forces are the ones that are going to prevent the movement, translation of rotation. So the beam is pinned into the wall, so the wall is preventing it from moving into the x direction. So that's why I have this force AX preventing it from moving in the y direction. That's why I have AY, and also it's preventing its rotation in this, which is expected from the 1200 newtons. So the wall is creating, or this pinning is creating a couple moment in the MA direction, and this way we have all the forces. We're going to talk about the direction of AX and AY and MA more when we solve the examples. So after doing this, you label loads and dimension on the free body diagram. All known forces and couple moments should be labeled with their magnitude and directions, and also all unknown forces and couple moments, we use the letters AX, AY, and MA around the point A here. And indicate any necessary dimensions for your free body diagram. And also, we're going to mention something that we created MA, the location of the couple moment should be very important when you select it. And we usually, in order to solve unknowns or use the equations of equilibrium, we select the point around which we want to measure the moment to be the point with the largest number of unknowns, especially the reactive forces. And we're going to solve a problem about this and show you how to do the example through doing an example. I hope that clarifies why we are interested in equilibrium of rigid bodies. It's the more realistic situation for engineers and the students to analyze, and also I've presented to you how can we create a free body diagram, what is a reactive force, and what are the process, what is actually equilibrium of a rigid body as opposed to equilibrium of a particle. Thank you for watching. Until next video. Bye.